Welcome to Module 1, Introduction to CI/CD. In this module, you'll get a broad introduction to continuous integration and continuous delivery, or CI/CD as it's commonly referred to, which is an automated approach to developing and delivering software with repeatability and reliability. You'll discover what CI and CD are and the benefits they bring when implemented properly in your DevOps pipeline. You'll explore popular CI/CD tools and see why it's acceptable for different teams within an organization to use different CI/CD tools, as long as they are eliminating manual procedures. You'll also learn about infrastructure as code, or IAC, which is the process by which you use code to automate the provisioning and the management of your infrastructure. IAC is a foundational concept for implementing automation. There are no labs in this first module, so the goal is to gain a high-level understanding of what CI/CD is before we dive deep into each topic individually. Let's get started. Welcome to What is CI/CD. After watching this video, you'll be able to explain what continuous integration and continuous delivery are, describe the key differences between continuous integration and continuous delivery, and explain the main benefits of CI/CD. It's important to understand the difference between continuous integration and continuous delivery, because a lot of times people say CI/CD like it's one process, but it's not. It's two separate and distinct processes that happen right after each other. Continuous integration is continuously integrating your code back into the main or master or trunk branch, so it shouldn't diverge too far before you merge changes back into the main branch to make sure that it works. You are continuously integrating your code with the main code base. Whereas continuous delivery is then taking that integrated code and deploying it somewhere. You may deploy it every time you integrate it, or you may not deploy it every time you integrate it. You may have continuous integration on one loop testing branches and pull requests, and then when you finally merge to main, you kick off the continuous delivery part. To define continuous integration, we say that CI is an automation process that allows you to integrate your work into your repository. You can also work as a team for the development of your application, and you can easily identify bugs and errors in your application very quickly. Your team can work in small chunks in different areas of your application and then easily and regularly merge the code into the main branch. Continuous delivery is the next phase after continuous integration. It prepares the code for the release of your application and automates the process that's required to deploy and build your application. Continuous integration and continuous delivery are broken into several distinct phases. Continuous integration consists of the plan, code, build, and test phases. This is where developers plan and then code the solution and then build it and test it in several repeating cycles until it's complete. And then the solution is ready to be delivered. While continuous delivery is made up of release, deploy, and operate phases, where the solution is released and the binaries are deployed into a given environment in repeating cycles, and the solution is then in live operation from that point on. It's important to differentiate them as we discuss CI/CD because they are two very distinct processes that cover very different phases. There is also a third concept called continuous deployment, which should maybe be called continuous release or something to make it less confusing because of the existing CI/CD terminology. The difference is subtle, and so when someone says continuous delivery, you usually know what they mean. But when someone says continuous deployment, you have to ask them, do you really mean deploying to production? Because that's what most people think of when you use the term continuous deployment. To avoid confusion, remember that continuous delivery is when you deploy it somewhere, like a development server, a staging server, a test server, or a pre-production server. Whereas continuous deployment is reserved for when you actually continuously push to production. So you'll hear these two terms, continuous delivery and continuous deployment, and it's important to understand that they don't mean the same thing. Continuous delivering is delivering it somewhere other than production, and continuous deployment is delivering it to production. It's also important to understand where CI/CD sits in terms of the DevOps pipeline. The DevOps pipeline consists of plan, develop, build, test, and deploy phases. And so when we talk about CI/CD, we're in the build and test phases of the DevOps pipeline. There are several key benefits to CI/CD. The first benefit is that you'll get faster reaction times to code changes. You're no longer waiting to see the effects of a change. It automatically gets built and tested and deployed. You'll also get the benefit of reduced code integration risk. The more often you integrate, the less time there is for change. So integrating more often means less risk of something breaking. Another benefit is that you get higher code quality with CI/CD because things are constantly being reviewed and constantly being tested, and every pull request is an opportunity for a code review. You also know the code and version control works. It's a common practice to ensure that the code in the main or master branch is always deployable. And lastly, CI/CD takes less deployment time because everything is already tested and deployments are automated, so they happen faster with greater repeatability. In this video, you learn that CI/CD is not one process. It's two separate and distinct processes that happen sequentially. Continuous integration is an automation process that allows developers to continuously integrate their code back into the main or master branch. Continuous delivery is the next phase after CI that takes integrated code and deploys it somewhere like a staging, testing, or pre-production server. Continuous deployment is delivering the code to production. CI consists of the plan, code, build, and test phases. CD consists of the release, deploy, and operate phases. CI/CD sits in the build and test phases of the DevOps pipeline, and there are several benefits to CI/CD. Welcome to Platform and Tools. After watching this video, you'll be able to understand it's okay to use different tools for CI/CD and identify some common tools for CI/CD. There are a lot of tools your pipelines can use even within the same company. Different line of business applications or LOBs within the single organization being run by different teams might be using different tools, and it doesn't matter that they use different tools. So their source code management system, their build systems, their continuous integration systems, their repositories, and so on might be running on different tools. Maybe there's Jenkins, there's Travis, there's Nexus, and there's JFrog Artifactory. But the specific tool being used isn't important. What matters is that they are using a tool to automate these processes instead of doing them manually. In fact, there's a plethora of tools for CI/CD that you can choose from. For example, if you look at just the CI box in the build column of this diagram of pipeline tools, you see TeamCity, Jenkins, Travis CI, Bamboo, CodeShip, Snap, and Go, to name a few. And you'll find that most of the top ones all seem similar and have similar ways of working and similar concepts. So if you try out a tool and decide you don't like it, you can just keep trying new ones until you find a tool that you like to use. Let's have a brief overview of some of the common tools for CI/CD. Jenkins is a CI/CD software that is installed on a server where the central build will take place. It's one of the oldest, most popular, and most complex of all the CI/CD tools. CircleCI is a CI/CD platform that can be used to implement DevOps practices. It performs deployments for continuous delivery, and you define workflows inside a circle.yaml file. Travis CI is a hosted CI service that helps developers build and test software projects hosted on GitHub and Bitbucket. Travis CI was the first CI service to provide free services to open source projects. It also performs deployments for continuous delivery, and you define a workflow inside a .travis.yaml file. GitHub Actions is a CI/CD platform that enables you to automate your build, test, and deploy GitHub workflows. Unlike other tools, it only works with GitHub. In this video, you learn that different line of business applications within the same organization may have many teams each using different tools. It's okay to use different tools for CI/CD. What's important is that the processes are being automated instead of being done manually, and there are lots of tools out there for CI/CD, and you can keep trying new ones until you find one that you like to use. Welcome to Infrastructure as Code. After watching this video, you'll be able to explain what infrastructure as code is, describe the benefits of IAC, and describe the various tools of IAC. Let's discuss what we mean by infrastructure as code, or IAC. It provides a great way for you to describe your infrastructure in a textual format. But I'm not referring to a word processing document. We're talking about a textual file format that you can actually use to configure your systems much like code. We're talking about textual code that you could hand to an IAC tool, and that tool reads the code and then builds your servers and networks and storage, etc. Essentially, the core infrastructure elements that you need. Using these tools with this textual code means that everyone gets the same environment every time, so it's consistent and repeatable. Textual code is normally written in the YAML format, which is a very common way to write and declare IAC. So why are we discussing infrastructure as code in this course? Well, performing these system configurations manually is error-prone, not to mention time-consuming. You can use templates or commands to describe how to install and configure the system according to your needs, how much storage you want, how much processing power you want, and so on. In the early days of DevOps, configuration management systems, or CMSs, made this possible, and they predated the newer IAC tools, so they were all that you had to perform tasks with. We'll discuss CMSs in more detail later. Due to repeatable configuration, you can rapidly provision the same platform over and over again and be sure that it will be in the same state every time. Infrastructure as code tools can be either declarative or imperative. With the declarative approach, you specify the desired state of the infrastructure resources you want to provision, and then the IAC tool determines how to achieve this state. It handles dependencies and executes commands in the proper order without you having to specify the order of execution. Tools that use this approach include Terraform, Puppet, SaltStack, CloudFormation, and to some extent Ansible. The imperative approach, in contrast, requires that you define the specific order of the commands needed to achieve the desired state. It's up to you to get the dependencies correct, as the tool will execute commands in the order you specify. Tools like Chef are imperative, and to some extent Ansible can be as well. Let's take a look at how Ansible uses inventory files and var files to see how they work as an IAC tool. Here, we're using Ansible playbooks as an illustrative example, but the process is essentially the same with other IAC tools. Chef has cookbooks and recipes, Ansible has playbooks and plays. They're essentially the same thing. Inventory files have a list of servers or devices that can be in the form of IP addresses or host names. They can also specify groupings of servers like all the web servers or all the database servers. This is how Ansible knows what to operate on. There are also var files that contain the relevant variables that may be needed whenever a playbook is run on a device or group of devices. You can control how Ansible interacts with remote hosts or devices based on how you define variables. The inventory files make up the most basic building block of Ansible architecture. You must reference the inventory file when executing Ansible or Ansible playbooks. So, Ansible has this notion of a playbook that contains any number of plays. Plays contain the instructions to be carried out on each server or device. Plays can be targeted to specific groups of servers like all the web servers or all the database servers. So, a playbook is a collection of reusable plays that are instructions that you give to Ansible to carry out. Ansible will read the playbook and determine which servers from the inventory that the plays are appropriate for and execute the plays on each of these servers. So you could determine that you need to set up a web server, an app server, a database server, or maybe 2 web servers and 3 app servers, or maybe even change the existing configuration of a server. Whatever you need it to do, Ansible will make all the necessary configuration changes and provision all the things you need for your infrastructure. It's also important to note that Ansible is idempotent. It will not affect a server if it's already in the desired state. This allows you to be able to reapply a playbook and not worry about installing things twice. Ansible will take care not to do that if it isn't needed. So, what are the benefits of IAC? IAC automation dramatically speeds up the process of provisioning infrastructure for development, test, and production, and for scaling or taking down production infrastructure as needed. It can even automate the provisioning of legacy infrastructure, which might otherwise be governed by time-consuming processes like requiring you to open a ticket and wait for someone to do it manually. Developers can quickly provision sandboxes and continuous integration, continuous delivery environments, and QA can quickly provide full fidelity test environments. IAC ensures that provisioning intelligence always remains with the organization. In the past, the knowledge of how to configure servers may have been known by only a few people in your organization. Once you codify this knowledge using infrastructure as code, everyone is able to provision what they need, and the fear of losing tribal knowledge through staff churn is no longer an issue. Finally, IAC lets organizations take maximum advantage of cloud computing's consumption-based cost structure. It reduces the time, effort, and specialized skills required to provision and scale infrastructure. It also enables developers to spend less time on plumbing and more time on mission-critical software solutions. Now let's briefly discuss some of the main IAC tools available. Terraform is an IAC tool by HashiCorp that is free and open source. It uses a declarative approach to IAC with a pre-execution check to ensure that it will do what you expect it to do. You can use Terraform as a base tool in combination with Ansible, where Terraform provisions the base infrastructure and Ansible configures the software on top of it. It's a very popular tool for cloud provisioning. Ansible is an open source tool that automates IT tools such as intra-service orchestration, application deployment, cloud provisioning, and more. It uses familiar YAML files to describe the state that you want to achieve. Ansible is simple to set up because it doesn't require any client-side agents or bespoke security infrastructure, and it works simply by delivering modules to the clients. This makes it ideal for memory-constrained environments like configuring Internet of Things devices. These modules are run on the client side, and the results are sent back to the Ansible server. Chef describes the necessary steps to reach a final state rather than describing the state itself. Using cookbooks, you can describe various processes by which you can configure a system to achieve the desired state. One of the strengths of Chef is that it's a popular tool and has lots of support, but one of the drawbacks is that its cookbooks are written in Ruby, so you need to have Ruby skills on your team. With Puppet, you could use any existing platform. The main difference between Puppet and Chef is that Puppet is declarative, which some consider to be a preferred method. SaltStack's remote execution capabilities allow administrators to run commands on various machines in parallel with a flexible targeting system. SaltStack is designed to allow users to explicitly target and issue commands to multiple machines directly. In this video, you learned that configuration management systems were really the only tools available to configure infrastructure systems before IAC tools became available. IAC tools can dramatically speed up the process of provisioning your development environment's infrastructure, and there are several different flavors of IAC tools available. Welcome to Module 2, Continuous Integration. This module will give you a broad overview of continuous integration, or CI. You'll start with learning the features of CI and the benefits it has for DevOps. You'll explore social coding, a practice that is widely used in the open source community and is being adopted for inner source by many companies who want to gain the efficiencies and benefits it has to offer. In support of that, you'll learn about the Git version control system and how to practice the Git feature branch workflow and the essential commands required to manage it. This workflow will ensure that you're following good DevOps practices and working in small batches so that your development work never strays too far from the main code base. Then, we'll look at some popular CI tools like Jenkins, CircleCI, TravisCI to compare the similarities and differences. But the tool that you will dive deep into is GitHub Actions. It's a relatively new tool that is rapidly gaining popularity, and it's available on every GitHub repository. We'll go into great detail on the events, runners, jobs, steps, actions that are essential components of the GitHub Actions workflow. In the hands-on labs, you'll fork a repo and set up your own GitHub Actions workflow to check out your code, perform quality checks and unit tests, and report code coverage automatically every time a pull request or push is made to the main branch. This is not some Hello World lab. This is a real-world example from one of my personal projects. You should be able to take what you've learned in the lab and immediately apply it to your own project. So let's get started. Welcome to What is Continuous Integration. After watching this video, you'll be able to define continuous integration, or CI, describe the main features of CI, and explain the difference between CI-based and traditional development. Continuous integration, or CI, is an automation process that, as its name implies, enables the continuous integration of code changes back into the main code base. It allows developers to regularly integrate their work into a repository so that their changes don't drift too far from the master or main branch. When a developer pushes their work into the source code repository, it ensures that the software continues working properly by automatically running a series of tests to detect any breakage. CI helps to enable collaborative development across the team because even if a developer forgets to run their unit test, the CI process will run the test for them and alert them of any failures. And this helps to identify any integration bugs sooner rather than later. Before diving into CI, you need to first understand traditional development. Traditionally, developers worked on large features or fixes and commit them to their own development branches. These branches can exist for a long time, have large scope, and generally require many code changes and edits. When development is completed on these branches, only then are they tested and merged into the main branch and built for production. This development method can cause drift between the main branch and the development branch, among other issues. The main features of CI are short-lived branches, frequent pull requests, and automated CI tools. In CI, developers work in short-lived feature branches where they develop their code. These branches are only meant for developing small features that contribute to the code so they could be merged back into the main or master branch quickly. The branch is deleted after it's merged, as its only purpose was to develop that small feature. This provides a couple of main benefits. It reduces drift that may occur between feature branches and the main branch, and critical or essential fixes may be implemented differently by multiple developers when working on their features. But with CI, developers can quickly implement a single fix that will be tested and merged, reducing parallel changes. Ultimately, this means you can deploy your code faster overall, as you don't need to run through a large code review because you've been checking the changes every time they've been pushed. Making frequent pull requests back to the master or main branch is a best practice. These pull requests are meant to contain code updates that serve a specific purpose. It makes code changes cleaner and easier to understand. A pull request requires approval from a repository maintainer or owner to be successfully merged. At a minimum, no one should be able to approve their own pull request. You want to ensure that every change has at least two sets of eyes on it. These frequent pull requests serve as small pieces of a much bigger puzzle, making it easy to build upon the most updated code. This function brings along with it many benefits. Each pull request needs to be reviewed, which facilitates increased collaboration among developers. It also enables developers to react quickly. Required changes can be tested and put into production faster, so solutions can get to the customer faster. And due to the frequency of continuous integration, you know exactly how much functionality you have built to date, reducing management risk. It improves your ability to predict when and if you will deliver the necessary functionality on time. Continuous integration can be automated, but what does that mean? Automated CI tools like those on the right subscribe to events such as pull requests and file changes using webhooks that can then trigger a workflow. That workflow can be anything, such as building an application. Once complete, these tools report back with messages of successful or failed build. These tools can run tests that ensure your file changes or pull requests don't break the entire application. With these automation tools, you can streamline your development process so that testing and checking your code is never tedious. In this video, you learn that CI is the process used to integrate code in small pieces frequently, taking advantage of short-lived branches. This encourages collaboration between developers who frequently discuss pull requests for concise changes. And there are tools that make implementing CI easy by streamlining development and testing. Welcome to Benefits of CI. After watching this video, you'll be able to explain the main benefits of continuous integration. The first benefit of CI/CD is that you get faster reaction times to code changes, because every time you make a change to your code and push it to a remote branch, the change gets tested. So even if you forget to run the tests, the CI tool will test it. Then the change gets built. So even if you forgot to check if the build works, the CI tool will check it. And then you can deliver the solution to your customer's hands more quickly, knowing that all of the tests have passed and the build is not broken. You also get the benefit of reduced code integration risk, because you're integrating smaller and smaller things. Smaller changes means less risk of something going wrong. So you're not having to integrate 100,000 lines of code into your millions of lines of code in your code base. Those days are over. You're only having to integrate maybe 10, 20, 30, 50 lines of code, for example. So you're not looking at a lot of code to handle. Remember, less change means less risk. Another benefit is that you get higher code quality with CI/CD because things are constantly being reviewed and constantly being tested. Every pull request is an opportunity for a code review. Forget about scheduling code reviews as a separate task. One of the things you should be doing as a best practice is when someone makes a pull request, you should go and look at the code. Have another set of eyes looking at what was changed while you're waiting for the test to pass is always going to be a good thing. During a review of the pull request, you can either say, yeah, looks good to me, or maybe you look at the title and it says the code needs to do this, but then you see some pieces of code and realize this code has nothing to do with that. So you ask, why are you changing this? You should also look at the tests and see if all the tests passed. Look at the code coverage. Let's say the code coverage went down. Your team has a standard of 95% code coverage, but the code coverage was only 91%. So what happened? Maybe somebody wrote code, but they didn't write a test case to run all the lines of code. So in your review of the pull request, you can simply say you don't accept it, and you can request more changes to the code. You could say the code coverage went down, and so I'm not going to approve this yet, and you can request that they write more test cases for the code. And then they can go and write more test cases, and the pull request will see the code changes and rerun the tests. If those test results look good to you now, you can say, okay, the code coverage is now above 95%, so now I approve the pull request. This kind of monitoring of each other's work is what you should expect from your development teams. This is what you want them to be doing. You want them to be monitoring each other, helping each other, looking at each other's code, and doing many code reviews, because it's a lot easier to do code reviews of 20 lines of code than 20,000 lines of code. These are the reasons that you do pull requests. You get a second set of eyes on the code and avoid something catastrophic happening without somebody knowing about it. You also know the code and version control works, because how are you going to do continuous delivery? Think about this for a moment. You're going to deploy from Git or some other source code management system where you keep your code. How do you know that the code in Git works? The answer should be, well, you ran your continuous integration test and they all passed. Unless you test every change, you could be deploying broken code to production. So it's very important to know that yes, everything that's in the master or main branch in Git works. In this video, you learn that CI/CD provides you with faster reaction times to changes, reduced code integration risk, higher code quality because things are constantly being reviewed and tested, and confirmation that the code and version control works. You also learn that your development teams should regularly monitor each other's work. Welcome to Social Coding. After watching this video, you'll be able to describe how source code is managed in social coding and explain social coding steps in practice. Source code management, or SCM, is the practice of tracking versions of source code as it is developed. This makes it easy to roll back to a previous version if errors occur. It also allows multiple people to work on different parts of the code and merge these changes into a single source of truth. Programmers use SCM tools to manage source code. These tools are also referred to as version control systems, or VCSs. You can use these two terms interchangeably when referring to software systems. SCMs can be centralized or distributed. A centralized SCM stores the code repository and version history centrally, and developers check out pieces of the code and work on it and commit changes back to the central repository. Builds must be done at the central repository because that's the only place that all of the code exists. With distributed SCM, each developer has a local clone of the entire code repository and version history. This means they can perform local builds because each developer has the complete code locally. So what is social coding? It can be referred to as open source for inner source. Social coding is something that open source community has been doing for years. What's new is bringing these concepts into the enterprise and coding as a community on internal projects. In the past, developers worked in private repositories or repos with limited need-to-know access and limited communications. This means no possibility of reusing code, and as a result, enterprises were continuously reinventing the wheel because no one knew the wheel had already been built. With social coding, repositories are public, and everyone is encouraged to fork the code and contribute. This is a vastly different way of thinking. Development teams love to think this is my code and no one can touch it, but they need to get over that for the good of the company. You would think that anarchy would ensue, but actually it works quite well because it's controlled by the repository owner. The person who owns the repository is still in complete control of the contributions. This is how social coding works in practice. You open a GitHub issue and assign it to yourself so that everyone knows you're working on it. You discuss the new feature with the repo owner and you agree to develop it for them. This allows you to leverage everything that they've done and add the feature that you need. Then you fork the repo, create a branch, and make your changes. When you're all done and you have something to contribute, you issue a pull request signaling that you are ready for a review, and the repo owner can decide whether to merge your code into the main project. The repo owners are in full control. They can ask for changes because they merged the code. They can ask you to write more test cases if you don't have adequate test coverage. They consider you an equal team member, and this is a win-win situation. You get to leverage another team's code and functionality, and the other team gets a new feature added for free. The company saves money because code is being reused instead of rewritten, and everyone is happy. This is how open source works, and this is how companies should treat their inner source. In this video, you learn that source code management helps developers track changes and manage their source code. Social coding is a practice that leads to high-quality code and increased collaboration. And there are 4 main steps to implementing social coding in practice, and each step flows into the next. Welcome to Git Feature Branch Workflow, Working in Branches. After watching this video, you'll be able to explain what Git is and why it's used for DevOps, analyze the workflow of working with Git in the Git Feature Branch workflow, and understand how developers work within Git branches when creating a new feature. Git is a distributed source code management tool used by developers worldwide. It was invented by Linus Torvalds in 2005 for Linux kernel development and is now the most widely used version control system. Code can be completely local, or it can be kept in a remote repository so that developers can collaborate. Every developer also has a full copy of the code. This differs from other version control systems that may only have developers check out the part of the code they are working on. This means that developers can work locally and track changes without having to contact a central repository every time. If something were to happen to the central repo, you would still have an entire copy locally to rebuild from. There are many ways to use Git in practice. Some of the most popular repository hosts are GitHub, GitLab, and Bitbucket. Git is the current standard for version control software. It completely changed how developers do their job, allowing them greater control over their code and the ability to roll back changes precisely if needed. GitHub is one of the largest platforms that developers can use to implement Git into their workflow, as GitHub hosts open source projects for free. This has enabled developer operations or DevOps methodologies that previously lacked a good way to implement them. DevOps benefits from Git because it can handle projects of all sizes, enables nonlinear collaboration, and tracks version control to ensure code quality. Let's look at how Git's used in practice. Here we'll demonstrate some of the most important steps and commands in an example Git workflow. Teams are free to adapt other workflows as well. Once a developer has made changes on the local clone of their code repository, they can run git add to move those changes to a staging area. The staging area allows developers to clearly separate the changes they want to commit, which may not be all their changes. I like to think of it as a shopping list. What do I need to buy the next time I go to the store? The staging area is your commit list. What file changes do I want to persist the next time I make a commit? This gives developers an area to double check they have exactly what they want to change ready to push. They can then run git commit to commit those changes to the version history of their local repo. This doesn't affect anyone else. It just changes the local repo. From there, the developer can continue working or finally push their changes to the remote repo using git push, where everyone can see and access those changes. For another developer to get those changes locally, they can run git fetch to fetch the most recent metadata of the remote repo, which describes all the version history and branch information, but does not actually pull the newest code changes. It allows developers to check if there are any changes without actually pulling any changes. This is so developers can avoid any potential merge conflicts. To get the actual changes and to download and merge their changes into their own workspace, they can run git pull, which will pull the most recent version metadata and any changes. If a developer wants to work on a specific branch of code locally, they can run git checkout to switch their workspace from one branch to another. Git looks in the metadata and makes changes to your local repository to show you exactly that branch's code. You can also use git checkout to get back to a previous commit. So this is great if you've gone down a path, you've made some changes, and then you decide, this isn't working for me, I want to get back to the last thing I committed. Just do a git checkout period, and that will get you back to your last commit. If a developer has made a commit but realizes that their changes are incomplete or incorrect, they can run git reset -- soft to undo that commit, but keep the changes in the staging area. Once they've made the necessary fixes, they can commit those changes once again. The last command is git reset -- hard. It's a very powerful and dangerous command. It will erase all changes made locally to a specific commit, so be mindful when using this command. This slide shows you the power of Git and how it can be used in a development process. Now that you understand the Git command workflow, we can look at how the Git feature branch workflow is used in social coding visually. You start by cloning a repo if you don't have it on your local computer, and then creating a branch. You want to make sure that you create a new branch for every new feature that you work on. Then as you're working on your code, making changes, you'll want to commit those changes. A commit gives you a checkpoint to go back to, so don't be afraid to make as many commits as you need. At some point, you're going to want to push those changes to a remote branch. This is like having a remote backup, so it's recommended you push your changes to a remote branch as often as needed, at least once a day. Then you open a pull request. It might be when you're finished, or it might be in the middle of doing development because you need to show people your code and ask questions. This is where discuss and review comes into play. This is all part of social coding. Once your changes have been reviewed, they will then get deployed to testing. And once all the tests have passed, then you can merge the code back into the main or master branch. Here's a sample workflow that developers may go through when starting development on a new feature. When using Git, always make sure you start off with the latest code. Check out the main branch and pull the new changes to your local workspace. When working on a new feature, make sure to create a new branch to work from. This is when a developer is ready to start developing that new feature. Once you've finished with your changes, you should stage your changes using the git add file name or git add period command and commit them with a good descriptive message. Be careful with git add period. Make sure you have a good .gitignore file, otherwise you may check in files that you didn't intend to. You can always use git status to see what's going to be committed. Only after that can you push your changes to the remote repo and track the branch that your changes are on. The -u option followed by the remote branch name are only needed the first time to create the remote branch, and any subsequent commits can be pushed without them. The whole process has 3 key components. We want to work off the latest code available, create a new branch to store our changes, and set up a remote branch to push our changes to. Say the next day you did some more work and now you have new changes to push. You would perform the same process as before. Add your code to the staging area, commit it with a descriptive message, and push that code to the remote repository. In this video, you learn that Git is an essential tool that enables DevOps and has many commands that provide essential functionality. The Git feature branch workflow is a process that many developers use in their job to develop clean, concise, and high-quality code. And that as a developer, using Git feature branch workflow is essential if you want to take advantage of all the benefits Git can provide. Welcome to Git feature branch workflow, making pull requests. After watching this video, you'll be able to explain what the Git feature branch workflow looks like in practice and describe the pull request workflow. If you recall in the Git feature branch workflow from a previous video, you are now on the final 2 steps of the process, where you must first issue a pull request and then merge your code. Let's review the pull request process. You start by checking out the main branch and pulling any new changes to the code to your local workspace. You can then switch to the feature branch that you have been making changes to and merge in any new code from the main branch. This ensures that you have the latest changes from the main branch included in your branch. Once any merge conflicts have been resolved and this process is complete, you can push your local branch to your remote repo. With this simple command, you can create and set a new branch in the remote repo to track your local branch. Finally, you can create a pull request and have it reviewed and merged into the remote repository. Before you make a pull request, be sure to complete the following tasks. First, make sure that you switch to the main branch before you run git pull so you have the most recent code for the main branch in your local workspace. Remember that the main branch contains the most current code because after changes are made, developers always merge back into it. Next, merge the updated main branch into your working branch so that it also has the most current code as well. This may cause merge conflicts that you'll have to resolve manually. Finally, you can push your updated branch to the remote repo, which is now ready to be merged back into the main branch. After your pull request has been merged, you should switch to the main branch and pull the most current code, which now includes your latest changes. To start fresh, delete the old feature branch you worked on, as the changes there have already been merged to the main branch. You can start developing on a new feature branch by creating it and checking it out. In this video you learned, you make pull requests in the last 2 steps of the Git feature branch workflow. You should always create a new feature branch to develop in. You need to remember to always pull updated code from the main branch before making a pull request. And you should delete the feature branch after the branch is merged. Welcome to Tools of Continuous Integration. After watching this video, you'll be able to describe how the Jenkins tool works, describe how the CircleCI tool works, and describe how the Travis CI tool works. Jenkins, the oldest of the 3 tools, implements both continuous integration and continuous delivery. It used to be the cream of the crop in this space. One of the things that made it so popular was that it is open source and you can run your own Jenkins servers. Jenkins has a large ecosystem of plugins to integrate with other tools such as Docker, Jira, and Maven. But the downside is this means there's many plugins to manage. You have to spend a lot of time making sure that all the plugins are up to date and secure, as well as compatible with all the other plugins. It describes a CI pipeline using the Groovy language in a Jenkins file. This requires users to understand a bit of Groovy to use it. The Jenkins file enables developers to treat their CI/CD pipelines as code, as you can see in this short example. It describes a simple pipeline with 2 stages to check out and test the code. To implement Jenkins into your workflow, you first need to set up your project on the Jenkins website. This is a drawback. As you will see, other tools allow you to specify a pipeline simply by adding a file to your repository, making them very repeatable. Requiring you to use a website for some configuration means manual steps that are not automatable and may not be reproducible. There are 2 ways to use Jenkins. We're going to cover the Jenkins pipeline workflow. To set up your repository for Jenkins pipeline, you need to create a Jenkins file to specify the CI instructions and place it in the root of your project repository. These instructions tell Jenkins how to run the pipeline to build and test your code. Jenkins can build your code in a virtual machine or inside a Docker container. You can also specify what actions trigger a build. Unfortunately, you can't do this in the Jenkins file. You must configure this on the Jenkins server using the user interface. You can specify to execute a build when you push to the master branch, whenever you issue a pull request, or on the occurrence of many other events. Now let's take a look at a realistic example of a Jenkins file. This example Jenkins file runs unit tests on a Python project. It has 4 stages. When Jenkins is notified by a webhook, it runs through the Jenkins file. At the top, it sets up the code to run in a Docker environment. The pipeline first checks out the code. The next step in this pipeline installs any specified Python package dependencies. Next, it lints every Python module in your code. This means it goes into your code and checks that it follows best coding practices. And lastly, it runs unit tests on your code. The process is straightforward and works similarly in other CI tools. CircleCI is provided as a service and implements both CI and CD. Because it's a service, you can't run this on your own server like you can with Jenkins, and it's not open source. It enables developers to treat their CI/CD pipelines as code, which is a common theme you'll see with all these tools. Similar to the Jenkins file with Jenkins, CircleCI uses a YAML file to specify the CI process, as seen in this short example that checks out the code, installs Python package dependencies, and runs some unit tests. The advantage of using YAML is that it is easily readable by both humans and machines and is a very popular format for configuring systems and services. To implement CircleCI into your workflow, you need to first set up your project on the CircleCI website. Unfortunately, this is a manual step. To set up your repository for CircleCI, you need to create a config file to specify the CI instructions. These instructions tell CircleCI when and how you want your code built. It can build your code in a virtual machine or inside a Docker container. You can also specify what actions trigger a build. You may see a pattern emerging. All of these tools in this lesson support both native and Docker builds and specify the pipeline instructions as code, like in the Jenkins file in Jenkins. So let's take a look at an example circle.yaml file. CircleCI natively supports languages such as Clojure, Java, JavaScript, Python, PHP, and some others. It also supports databases such as MySQL, MongoDB, and Postgres. Since it supports Docker, anything you can build in Docker, you could build with CircleCI. This section of the YAML file asks CircleCI to get a Docker Python image and sets an environment variable for the database URL. The next section sets up PostgreSQL and several environment variables to configure Postgres. Once the environment is set up, it checks out your code, installs packages, and runs tests. Clearly, you can see a pattern in how both Jenkins and CircleCI work. Travis CI is just like the other 2 tools. It implements both CI and CD. Like CircleCI, Travis CI is a hosted service, which means you cannot run it on your own servers. It's only available as a service. You can, however, get an enterprise license and run it internally in your own company. Also like CircleCI and Jenkins, you must set up your project first in their admin UI, which is a manual step. It enables developers to treat their CI/CD pipelines as code. Unlike CircleCI, it supports many more languages and databases natively, as well as Docker, so you can really run anything with Travis CI. And like CircleCI, you use a YAML file to specify the CI process, as you can see in this example, that requests a Python 3.9 environment, installs dependencies, runs unit tests, and uploads the code coverage. That's a lot of functionality for a little file. To implement Travis CI into your workflow, you first need to set up your project on the Travis CI website. This is a manual step, but unlike Jenkins and CircleCI, Travis allows you to enable it for all of your repositories, so it only has to be done once for all of your repos. Next, to set up your repository for Travis CI, you need to create a .travis.yaml file and place it in the root of your repository. These instructions tell Travis when and how you want your code built. You can build your code in a virtual machine or in a Docker container. Like the other tools, you can specify what actions trigger a build, but unlike the other tools, this is not done in the travis.yaml file. It can only be done manually from the Travis CI admin UI, just like Jenkins, which is a drawback. As you can tell, each of these tools provides a means to reach the same goal, enabling continuous integration of your code. Let's take a look at an example Travis YAML file. Like the other two tools, the .travis.yaml file defines the instructions to run the build. The top of this file specifies the language to use to build the code. Then it requests a PostgreSQL database, sets an environment variable to the database URL, and provisions a test database to run the tests with. After that, it installs the required Python dependency packages. Once the environment is set up, this script then tests the code. And finally, it collects and uploads the test results to codecov.io. This is a very simple example, but it shows that it doesn't take much to automate continuous integration with Travis CI. There is one more tool we didn't mention in this overview, and that's GitHub Actions. GitHub Actions is a CI/CD tool that is available in every GitHub repository. It is integrated into GitHub as a service. It allows you to fully treat your CI pipeline as code and is controlled by YAML files. GitHub Actions will be covered in more depth in subsequent videos, and it will be the tool that you use in this course. In this video, you learn that there are many automated CI tools out there with different pros and cons, and most of them have similar characteristics. Each of these tools provides CI pipelines that can be written as code, enabling automation and repeatability. And tools such as CircleCI and Travis CI are offered as services so that you don't have to worry about managing them. Welcome to Module 3, Continuous Delivery. This module will give you a broad overview of continuous delivery, or CD. You'll start by exploring the goals, benefits, key principles, and best practices of CD. Then you'll discover the requirements of a CI/CD pipeline and the differences between continuous delivery and continuous deployment, a closely related process. You'll also learn about some popular CD tools, compare and contrast their features and benefits, and learn how to choose the best tool for your needs. Then we'll dive deep into exploring Tekton, a cloud-native CD tool that executes right in your Kubernetes cluster. You'll discover its essential components of events, triggers, pipelines, tasks, and steps, and how they work together to create a complete CD pipeline. Starting from the bottom up, you'll learn how to build a pipeline from Tekton tasks, pass parameters into the pipeline and build triggers, and start pipeline runs from webhooks that you create with your favorite version control system like GitHub and GitLab. You'll also learn how to use community written tasks from the Tekton catalog, otherwise known as Tekton Hub, and how to write your own custom tasks when the catalog doesn't have one that you need. Finally, you'll learn how to build a container image and deploy it to OpenShift as the last step in your CD pipeline. The hands-on labs will allow you to implement everything you've learned in the videos. They take you step by step through the process of creating a fully functioning CD pipeline that clones a repo, performs quality checks, unit tests, builds an image, and deploys it to Kubernetes. In the end, you'll have a fully functioning pipeline that you could use with or modify for your own projects. So let's get started. Welcome to What is Continuous Delivery. After watching this video, you'll be able to differentiate between continuous integration and continuous delivery, describe the goals of continuous delivery, and explain the benefits of continuous delivery. The first thing that's important to understand is the difference between continuous delivery and continuous integration, because a lot of times people say CI/CD like it's one thing, but it's not. It's two separate and distinct things that happen after each other. Continuous integration is continuously integrating your code back into the main or master or trunk branch, so it shouldn't get too far away before you merge stuff back into the main branch to make sure that it works. You are continuously integrating your code with the main code. Whereas continuous delivery is then taking that integrated code and deploying it somewhere. You may deploy it every time you integrate it. You may not deploy it every time you integrate it. You may have continuous integration in one loop, and then when you finally merge to your main branch, you kick off the continuous delivery part. The term continuous delivery can be defined as a series of practices designed to ensure that code can be rapidly and safely deployed to production by delivering every change to a production-like environment. Notice that it says production-like. It doesn't have to be a production environment, and many times it's not. In fact, deploying to a production is usually called continuous deployment. Continuous delivery just means that you're deploying the code to a development or test or staging environment to ensure that the code can be deployed. This also gives everyone a chance to see the code working. The key takeaway is that this is automated. Nobody performed any manual steps to deploy the code. It is continuously deployed automatically. So what are the goals of continuous delivery? Well, according to Martin Fowler, continuous delivery is a software development discipline where you build software in such a way that the software can be released to production at any time. Let's dig deeper into what that means. To release to production at any time means that the main or master branch must always be deployable, which means that you've got to have a set of checks in place to make sure that you don't get bad code into that main or master branch that could break your product. And this is absolutely key. And that's why you use continuous integration to run the tests every time there's a pull request. Working in separate feature branches and using pull requests ensures that any code you have written is working correctly before you merge it back into the main branch. The benefits of continuous delivery are many and varied, and they include the following: enabling your development teams to automate the steps that transport software through the various stages of the software development lifecycle, or SDLC. Automation leads to reducing the deployment time by non-stop testing and deployment cycles. The more you deploy, the more confidence you have that your next deployment will work, and the less time you spend debugging deployments. Reducing the costs that are normally common with standard deployment strategies. This could be people costs, infrastructure costs, and the cost of lost time due to manual failures. Continuous delivery enables your development team to scale their software deployments based on the size of the project. And enabling you to deploy code automatically into the various stages of the software development lifecycle. Once you have deployed to the development environment without incident, and to the test environment and then the staging environment all without incident, the chances are pretty good that when you deploy to production, that will also be without incident. In this video, you learn that CI/CD is not one thing. It's two separate and distinct things that happen after each other. Continuous delivery is taking integrated code and deploying it somewhere. Continuous delivery is a software development discipline where you build software in such a way that the software can be released to production at any time. The reason you have pull requests and feature branches is so you can ensure code changes work before you merge them back into the main branch. And your code will typically need to go through several stages, quality assurance and staging or testing, to ensure that what you deliver to production is bug-free and fit for purpose. Welcome to Continuous Delivery Key Principles. After watching this video, you'll be able to describe the 5 key principles of continuous delivery. The first of our key principles of continuous delivery is to build in quality. You need to ensure that you have quality built in at every step. Quality isn't free. You must plan for it. This can be achieved by continually reviewing your code. Every pull request is an opportunity for a code review and quality check. This is critical to make sure that everything looks good all the way along your pipeline. The next key principle is to work in small batches. That's why you should make your user stories small. It's best to make small changes because less change means less risk. And you should continuously integrate these changes with the base code so that the changes never drift too far from the base that everyone else is working from. The third key principle is knowing that people are great at solving problems, but not so good at repetition. So people shouldn't be required to perform repetitive tasks. In fact, people are terrible at performing repetitive tasks. They get easily bored and distracted. With test-driven development, you could constantly pull people's code and run tests against it manually. But why not harness the power of computers to perform these repetitive tasks that they were designed to handle? Computers can perform these tasks more quickly and efficiently than you or I. For example, applications such as GitHub Actions could do that job and you would never have to pull and test code manually again. The next key principle of continuous delivery is that it enables relentless continuous improvement. The more often you do something, the better you get at it, and the less likely it is to fail. By delivering each change to a known working environment, you should continually know where you are and when things are broken. And the last key principle of continuous delivery is that everyone is responsible for their part in the story. So if a build does break, it's not a case of finger pointing and asking whose fault is it. What you should be asking is, what went wrong and how can we prevent this from happening in the future? What you need to consider is more about the system's failings rather than the people's failings. How did the system fail the people, not the other way around? In this video, you learn that you need to build in quality, you should work in small batches. People are best at solving problems, not repetitive tasks. You need to relentlessly pursue continuous improvement, and everyone is responsible for their part in the story. Welcome to Continuous Delivery Practices. After watching this video, you'll be able to describe continuous delivery best practices, explain the requirements of a CI/CD pipeline, and describe the differences between continuous deployment and continuous delivery. There are many best practices to follow when implementing continuous delivery. It's important to make every change releasable. This means you should always include user documentation, operations runbooks, and information about what your change does. This ensures that every change will work and be documented well enough to be delivered to customers as well as serve any audit that may occur. You also need to keep in mind that continuous delivery is built upon continuous integration. As a best practice, you should avoid delaying any integration caused by long-lived branches. You want to use short-lived feature branches that are continuously integrated into the main code base. This is also called trunk-based development because you always come back to the trunk, otherwise known as the master or main branch. Every change is built, tested, and deployed together for the fastest feedback. A well-constructed automated delivery pipeline is integral to successful continuous delivery implementation. This ensures that all code releases move into the test and production environments in a consistent, predictable way. Automate as many processes as possible. In continuous delivery, you must automate as many processes as possible in your software development lifecycle to create a good, reliable delivery pipeline. This pipeline is not only for code builds and deployments, but for creation of new development environments as well. You want to aim for no downtime. To ensure application availability while you make frequent continuous delivery updates, when you push a new function to production, you must first validate it before deploying it to public running application instances. You also want to release at the granularity of test. If two parts of the system must be tested together, they should be released together so that you know that the parts of your system are compatible. Release automation tools are good at coordinating this kind of delivery. Alternatively, you can fully decouple. A CI/CD pipeline requires several elements to be in place. You need a code repository to host and manage all source code. Your source code management system is the single version of the truth. Everything you need to build and release your code must be checked into version control. That code needs a build server to manage the building of the application. You want that environment to perform clean builds starting from the same state every time. You need an integration server or orchestrator that handles the build automation and runs tests against your code. There should be no manual steps. Everything should be automated. And finally, you need a repository to store all the binaries and artifacts of the application so that once built and tested, they can be deployed easily. So what's the difference between continuous deployment and continuous delivery? Continuous deployment can be part of a continuous delivery pipeline. Specifically, continuous delivery is the automated movement of code through the development lifecycle or delivery lifecycle once it passes the required automation test. Continuous deployment is taking that delivered code and deploying it into production. Whether and how continuous delivery is implemented all depends on your business needs. If your business needs the delivery team to release new or updated software to production repeatedly, reliably, and quickly, then continuous deployment will be of great benefit. In this video, you learn that there are several best practices to follow when implementing continuous delivery. A CI/CD pipeline requires a code repository, build server, integration server, and storage repository. Continuous delivery is the practice of automating the movement of code through the development lifecycle. And continuous deployment is the practice of taking the delivered code and deploying it into the production environment. Welcome to Tools of Continuous Delivery. After watching this video, you'll be able to describe the different tools that enable continuous delivery, or CD, explain what to look for when choosing a CD tool, and describe the Argo CD and Tecton tools for CD. There are many tools available to the average developer for performing continuous delivery. Jenkins is one of the older CI/CD tools on the market and one of the most popular. It has a huge community and supports countless plugins, but it's not ideal for CD. Jenkins does not provide visibility into the pipeline process and requires a lot of setup and maintenance, making it uncompetitive compared to other CD tools. Spinnaker, on the other hand, is a dedicated cloud-agnostic CD tool built in-house by Netflix. It allows you to manage CD pipelines and simplifies release rollbacks. It supports the creation of load balancers and scale clusters all natively. CircleCI is a tool that also contains CD capabilities and was initially built with containers in mind, although you can still run things on virtual machines. The containers are highly scalable, and due to the container-first approach, every step of the build is very flexible. You just point to a Docker image to build from. Lastly, GitLab can implement both CI and CD. It's easy to automate the process of deploying code to production since GitLab is also a source code manager. It supports all major cloud platforms, making the CI/CD pipeline very flexible to build. Travis CI is another CI tool that contains CD capabilities. It isn't as feature-rich as other CD implementations, but it requires minimal maintenance. Tecton enables you to build, test, and deploy apps in Kubernetes using an open-source, vendor-neutral framework. Its main strength is its modularity, allowing you to deploy across multiple environments such as VMs, serverless, Kubernetes, and cloud providers. GoCD is a tool that boasts easy pipeline setup with native Docker and Kubernetes support. It comes with its own value stream map tool and helps you trace each pipeline through all of the stages between commit and deployment. You can build pipelines with YAML or JSON files in a visual UI. And finally, Argo CD was originally developed by Intuit as they were looking for a lighter tool than Spinnaker that would improve build and deployment times and streamline their GitOps workflow. The UI is well made and easy to use and integrates well with a variety of CI tools such as Jenkins, GitHub Actions, CircleCI, and more. When looking for a CD tool to use within your workflow, these key considerations should be top of mind. With CD, you may want full audit trails, proprietary integrated secrets, and fine-grained role-based access control. These features may only be partially available in CD tools and not ubiquitous, as some tools may be very new and overly simplistic. Having a feature-rich CD tool means that once your applications become more complex with more moving parts, you'll already have the features at your disposal. Depending on your CI pipeline, some CD tools may not be compatible with your current process. Picking a tool that's compatible and easily integrates with your current tool set makes setting up CD faster and reduces potential headaches. CD tools can differ greatly in how they are implemented and how easy it is for developers to set up CD in their projects. Tools like Tekton are easy to set up and provide clear insights into your pipelines. Beyond setup, maintenance can also take a lot of time. Tools like Argo CD are easy to set up and maintain, while Jenkins is a handful to both set up and maintain. Using a CD tool to build a pipeline is just the first step. You must also consider what tools you'll need within your CD pipeline to perform the following tasks. Within your pipeline, you need tools for application security scanning and ensure overall application health. Security is often an afterthought and added at the end before an application launches. By adding security checks to your pipeline, every change that you make along the way is tested to be secure. Vulnerability scanning helps identify dependencies and components vulnerabilities. Applications that are not vulnerable one day suddenly become vulnerable because of exploits found in existing code or libraries. It is critically important to add vulnerability scanning to your CD pipeline to ensure that you are not shipping code with known vulnerabilities. Secret scanning for API keys and credentials prevents accidental exposure of sensitive information. Many times, developers inadvertently place passwords and other credentials in files that have been erroneously checked into source control. Scanning for secrets ensures their credentials are not leaked. Static application security testing, or SAS scanning, identifies vulnerabilities of the entire codebase, such as SQL injections and cross-site scripting. While some of these mistakes might get identified during code reviews, it's important to ensure that your CD pipeline is checking for them in case your developers forget to. Dynamic application security testing, or DAST, scans for incorrect security assumptions that may be hidden in the source code. Dynamic scanning checks the running application for weak spots. Better to catch these in your CD pipeline than have malicious users find them in production. Lastly, a CD pipeline also requires a tool that facilitates code deployment. Automating deployment ensures that they are repeatable so that you get the same results regardless of whether you are deploying to development, test, staging, or production. A relatively new tool that is gaining in popularity is Argo CD. Argo CD is a declarative continuous delivery tool that makes CD easy to automate, audit, and understand. It follows the GitOps pattern of using Git repositories as a single source of truth for defining the desired application state. Argo CD, as a Kubernetes controller, monitors the current application state compared to the desired state, visualizes the differences, and ensures parity by automatically syncing. Since we'll be using Tekton in this course, let's take a brief look at it. Tekton is a flexible, open-source framework that abstracts the implementation details so you can focus on building, testing, and deploying according to your project's requirements. By standardizing the CI/CD tooling and process, Tekton works well with other CI/CD tools such as Jenkins, Scaffold, and Knative. Tekton pipelines are fully portable, so once they're created or defined, a developer in the organization can take a pipeline and reuse its components. In this video, you learn that there are many continuous delivery tools available to choose from. A good CD tool should be feature-rich, easy to use, highly compatible, and require low maintenance. Scanning and deployment tasks should be handled by tools within the CD pipeline. Argo CD is a declarative continuous delivery tool implemented as a Kubernetes controller. And Tekton pipelines are fully portable so developers can reuse their components.